Your phone can find you from space, understand a fingertip through glass, and erase the roar of an airplane. None of that is magic. The strange part is that each trick works in a completely different way, and one of them only works because engineers correct time itself. Wi-Fi. When you tap a video, your router does not throw tiny ones and zeros across the room. Wi-Fi is radio. The digital information changes or modulates properties of an electromagnetic wave, and your phone turns those patterns back into data. Think of it like changing the rhythm of an invisible flashlight beam. Your phone also talks back, so streaming is a non-stop two-way conversation with the access point. Why does your phone hear your router instead of every router nearby? Wi-Fi uses radio channels, and each data frame includes source and destination addresses. Networks can still interfere when they crowd the same channel, making service painfully slow in a packed building. With modern WPA protection, the traffic is also encrypted. Your cat video is basically traveling inside a locked invisible envelope. Touchscreens. Your phone screen usually does not detect how hard you press. It detects how your finger changes an electric field. Beneath the glass is a transparent conductive grid. Because your body conducts electricity, bringing a finger near it changes the capacitance, the grid's ability to store charge, at one location. The controller locates that change and reports coordinates. The app decides whether they mean tap, swipe, pinch, or accidentally like a photo from 6 years ago. That is why ordinary winter gloves often fail, while gloves with conductive fingertips work. The screen is not feeling you. It is measuring your electrical effect. Microwave ovens. A microwave does not cook from the inside out or make food radioactive. Microwave energy is absorbed by parts of the food and converted into heat. Water molecules are especially important because they are polar. One side is slightly positive and the other is slightly negative. The rapidly changing electric field pushes those molecules to reorient again and again. Their motion transfers energy through the food as heat. But microwaves do not penetrate thick food evenly. The outer region absorbs much of the energy, while heat reaches the center mainly by conduction, the same slow-spreading process that heats the middle of food in a regular oven. That is how your lasagna can be volcanic at the edges and still contain a frozen archaeological site in the center. The rotating plate moves food through stronger and weaker energy zones. It does not create heat, it helps distribute it. Dreams. You can spend the day answering emails and then dream that your dentist is driving a school bus across the moon. Your brain clearly has an unusual after-hours department. Vivid dreams are common during REM sleep, the stage when your eyes move rapidly and brain activity rises, but dreaming can also happen during non-REM sleep. Scientists still do not have one proven answer for why we dream. Sleep supports memory and learning, and dreams may reflect the brain processing memories and emotions. Recent experiences mix with older memories, fears, places, and people. It is less like replaying a video and more like dumping 10 folders onto the floor and building a story. During sleep, systems involved in careful reality checking do not operate exactly as they do when you are awake, so you may accept impossible events without asking questions. Flying whale giving a job interview? Apparently qualified. If one of these explanations has already changed how you see an everyday object, tap like, and let's keep going. YouTube recommendations. Watch one video about restoring an old toaster and suddenly your homepage thinks antique appliances are your life's purpose. But YouTube is not reading your mind. It is estimating what you might enjoy from a huge collection of signals. Signals include watch and search history, subscriptions, likes, dislikes, feedback, and satisfaction surveys. Watch history strongly affects the homepage, while your current video is a major clue for what plays next. The system also compares viewing patterns. If people with habits like yours enjoy video A and then video B becomes a reasonable suggestion. The algorithm only needs to notice the repeating pattern. It is not optimizing only for a click. YouTube also uses satisfaction signals because a video can hold your attention without making you glad you watched it. So your homepage is not a fixed portrait of who you are. It is a prediction that changes every time you feed it new evidence. Bluetooth. In a crowded cafe, dozens of earbuds, watches, keyboards, and phones can share the same radio neighborhood without turning every song into electronic soup. Classic Bluetooth handles this partly through frequency hopping. A connected group follows a synchronized pseudo-random pattern across as many as 79 radio channels, with a standard rate of 1,600 hops per second. Both devices know where and when to jump, like two people changing meeting rooms according to the same secret schedule. Adaptive frequency hopping can avoid noisy channels. Pairing and authentication establish the right relationship, so your call does not jump into a stranger's earbuds. The name comes from Harald Bluetooth, a 10th century Danish king associated with uniting groups. Engineers liked the parallel, their technology-connected devices from different companies. A medieval nickname ended up inside your earbuds. Active noise cancellation foam can block sound. Active noise cancellation does something stranger. It fights sound with more sound. Microphones on the headphones listen to the surrounding noise. A processor estimates the incoming waveform and asks the speakers to produce an opposing waveform. When the pressure peaks of one line up with the pressure dips of the other, they partly cancel through destructive interference. Imagine two people pushing a swing with equal strength in opposite directions at exactly the right moments. The motion shrinks instead of growing. It works best on steady, low-frequency noise like an airplane engine. Sudden voices and sharp claps are harder because the sound changes before the system can respond. The ear cups add passive blocking, so both methods create the final quiet. Your headphones are not deleting sound from the room. They are creating a carefully timed second sound that makes less noise reach your eardrum. GPS. When the blue dot appears on your map, your phone usually is not announcing its location to GPS satellites. It is listening to clocks in space. Each satellite broadcasts a timed signal and orbital information. Your receiver measures the signal's travel time. Since radio waves move at light speed, that delay reveals distance. One distance places you somewhere on a huge sphere. More satellites narrow the possibilities. A receiver typically needs at least 4 to solve for three-dimensional position and correct the error in its own clock. The blue dot is where the math agrees you must be. Now for the part that sounds fictional, GPS has to account for Einstein's relativity. Satellite clocks move quickly, which makes them run slightly slower from our perspective, but they also experience weaker gravity, which makes them run faster. Combined, GPS satellite clocks would gain about 38 microseconds per day relative to clocks on Earth. That is less than the blink of a blink, yet without correction, location errors would grow by roughly 10 kilometers per day. Your phone finds the coffee shop because engineers remembered that time does not pass at exactly the same rate everywhere. Black holes movies treat black holes like cosmic vacuum cleaners, chasing everything in sight. But if the sun could somehow be replaced by a black hole with exactly the same mass, Earth would keep orbiting in almost the same path. We would freeze without sunlight, which is admittedly a major scheduling issue, but we would not be instantly sucked in. A black hole is a region where gravity is so intense that beyond a boundary called the event horizon, nothing, not even light, can escape. Some form when massive stars reach the end of their lives and their cores collapse. The origins of supermassive black holes are still being investigated. Black holes are dark, but their surroundings can shine. Falling gas can form a hot disk and release radiation before crossing the event horizon. Astronomers also detect stars orbiting an invisible mass or watch its gravity bend background light. As for the center, general relativity predicts a singularity, where our current equations reach their limit. That is not science saying, mystery solved. It is physics putting up a sign that says, new theory needed beyond this point. These things seem unrelated, but each hides an invisible system beneath an ordinary result. Radio waves, electric fields, molecular motion, probability, timed signals, and curved space-time. The world does not become less amazing when you understand it. You simply get to see the machinery behind the trick. Tell me which explanation surprised you most, and subscribe for more complicated things made simple.